right, this video is going to talk about the division properties with exponents. Hopefully you've already learned about the product properties or the multiplication properties. So let's go over those multiplication properties very quickly, and then we'll show you the similarity when it comes to some quotient properties when we're doing some division. So first of all, we've got three different examples on here. I'm going to start in the upper left. First thing I'm going to do is take that power of 2 that's outside my parentheses, and I'm going to go ahead and apply it to all the parts inside. We have a rule that says if you have products inside, products to a power, well, 4 squared then, v squared, and w cubed, right, squared, would be one move that we can do. We can make everything to the second power then. In that case, we can simplify a little bit more. 4 squared would become 16. And again, there it depends on, do you want exponent, property or exponent form, right? Leave it as 4 squared, or do you want to actually simplify it? It says up here simplify, so we're going to go all the way to 16 here. Then v squared is just v squared, but in that next property we have, well, power to a power, right? W to the third to the second. We have a property, sorry, that says 3 times 2 then, power to a power, you multiply. So again, this is going to be 16 v squared w to the 6th. We can kind of do the same thing over here to the right. Now notice we've got this negative going on in here, but again, 5 is an odd exponent. So I already know I'm going to get a negative answer. So that negative 1 to the 5th, technically, right, is what that is going to stay negative. Then I've got a 2 to the 5th, again an r squared to the 5th, and an s to the 3rd. Right, to the 5th, which makes for a negative 2 to the 5th is 32. You can double check that, multiplying all your 2's out. R to the 10th and S to the 15th. So we get a nice answer there. And then finally down here at the bottom, we've just got a little more of that going on. Again, I'm going to kind of go through this fairly quickly. Taking my powers to the 4th, x to the 4th. Again, y to the 3rd to the 4th will become y to the 12th. We can kind of shortcut that a little bit. Then we just have some more multiplying. We've got a 4, right? An x squared and a y to the 5th. Well, 2 to the 4th would have been 16. And 16 times another 4, right? Those are all numbers. 16 times 4 is going to be a 64. So again, multiplying all that out, we get just a nice coefficient of 64. Then we've got x to the 4th times x squared. I'm going to add those exponents. So that becomes x to the 6th. And y to the 12th times y to the 5th. Again, same thing. I've got a grand total of y to the 17th, right? Adding those two exponents. Now, again, we had kind of three main properties there. We've got that property to say that outside exponent can sort of be moved in to all the parts. We've got that power to a power property, right, that we showed down here, right, y to the, or w to the 6th in that first example. And then in that very last example, we had multiple things, x to the 4th times x squared. Again, if you're multiplying equal bases, we add the exponents. Well, similarly, we've got some division properties. And the idea is this: if we're dividing, well, now we're trying to simplify. We've got x to the 5th, which is x times x times x times x times x, all over, again, x times x times x. If we simplify that a little bit, again, anything multiplied on the top that's also multiplied on the bottom, we can sort of get rid of, right? So again, I'm going to get rid of 3 x's, both top and bottom, basically leaving me with 2 x's on the top, or basically x squared. Well, a simpler way of doing that is to notice that if it's x to the 5th on top and 3rd on the bottom, similar to if you have equal bases multiplied, then we add the exponents. Well, if we have equal bases divided, why not subtract the exponents? Subtraction is just addition with a negative, right? So we can subtract those exponents, and notice we still get x squared. So again, that's the idea of this property down here at the bottom. If we're dividing with equal bases, subtract your exponents. We also have a property that says if there's multiple things, right, a whole fraction to a power, similar to multiplying, we can just apply this outside 2, right, this outside power to both parts. And that's what it's showing you down here at the bottom. If A is divided by B, but they're both to the m, then you can separate that and make them both to the m. So this is going to be x to the 8th squared over y to the 5th squared, which becomes x to the 16th, right? A little power to a power property, y to the 10th. But now notice they're not equal bases, so I can't use that last property we looked at. I can't subtract them because, again, they're not equal bases, right? Only with equal bases can you subtract those exponents. Let's take a look at a couple examples. Again, there's really only a couple of properties for division here. We've already covered the rest of those properties. So let's take a look at these. And go ahead if you want to, at this point, feel free to pause the video or pause between the examples and try that next example. See what you end up with. And then you can always watch the video to double check your answer. So we'll just give it a second here. And now if you're ready, I'm going to go ahead and start working. Hopefully you've already got your answer worked out. We've got 2, again, times x. But remember, if they're multiplied both to the 4th power, then I can say 2 to the 4th, x to the 4th. And at the same time, I'm going to say that this y squared on the bottom is also to the 4th. Right? Top to the 4th, bottom to the 4th, and the things that are multiplied, right? The 2 and the x, both to the 4th. So 2 to the 4th would be 16. We've just got x to the 4th there. And on the bottom, power to a power says y to the 8th. So I would say that's the simplest what we're going to get right there. Same thing goes for the one in the middle. Again, we've got a fraction to a power, so let's say x to the 3rd to the 5th, and x squared to the 5th. So that becomes x to the 15th, right? Power to a power, and x to the 10th. And then we can use our subtraction rule because they're equal bases. 15 minus 10 just becomes x to the 5th. And that would be our best final answer. Now up top here, notice we've got 2 big old fractions multiplied. Now I can do a little bit of simplifying. You might notice I've got some x's over here I could maybe get rid of, or some y's in the second example that maybe we could deal with. But what I'm going to do actually is go ahead and put them together first. As long as we're multiplying fractions, let's just multiply the top. 2 times 9 is going to be 18. We've got an x to the 3rd, right, times an x to the 1st. So that would be x to the 4th. We'd add our exponents. Again, y to the 7th times y squared. Well, 7 plus 2 would be y to the 9th. And we'll put that over. We'll notice on the bottom we had a 3 multiplied. We've also got an x, and we have a y to the 4th. We didn't really have any like parts, but again, we're going to make that one fraction. If you're multiplying fractions, you just multiply the top, multiply the bottom. Now, let's do some simplifying. And if you're seeing too many parts all at once, what I would recommend is sort of separate it. We've got our coefficients, we've got our x's, and we've got our y's. So 18 divided by 3, well, no, those are just numbers, so don't get too overzealous here. I know in the middle where we're saying x to the 4th over x, well, that means we take x and we subtract the exponents, right? 4 minus 1 would be 3. But remember, 18 divided by 3 is just 18 divided by 3. This isn't an exponent question. 18 divided by 3 is just 6. We just divide the numbers. And then the same thing for the last one. Again, we've got y divided by y, but again, we need to deal with those exponents. So again, I'm going to divide y to the 9th by y to the 4th, meaning 9 minus 4, I'm going to get y to the 5th power. Right? Again, the equal base is divided. What I'm really doing is canceling those y's away, right? Because really, this was y to the 4th times y to the 5th, right? There were 9 of them all over y to the 4th, right? So again, I just cancel away the y to the 4ths, and we end up with that y to the 5th over here, right? So just keep that in mind. Again, you're dividing the bases, but the shortcut is to subtract the exponents then, if there are exponents to subtract. I hope that helps you again with the division properties of exponents and a little bit with the multiplication ones as well. Good luck simplifying. If you have any questions, talk to your teacher, and have a great day.